Okay, welcome everyone to the session where we are going to talk about what we're doing with Kubernetes and modern apps and everything like that in our platform in VCF 9. So in this presentation, we'll go through a little bit of what's new. I'll show you some slides, and then also I'll show you some demos of what we're working on. So now that people are joining, I may just give it a few more seconds just to see if everyone is in, and then we can start. Okay, so let's get going. My name is Katarina Brookfield. I'm part of the VCF technical marketing team here at Broadcom. And as mentioned, in this session, we will talk about what's new at vSphere Supervisor and what we're doing in general with our Kubernetes operations in VCF. So in the opening keynote, Paul mentioned that we are trying to deliver this private cloud. And with that comes this cloud experience. And in order to give you the best cloud experience, we really need to cater to these different personas, whether that's cloud admins on one side, still having that governance and control over the infrastructure that we are deploying, but also on the other side, to have that consumer experience where you have access to a lot of services that are very easy to use and are supporting all of the functions that you need for your workload. And that's exactly what we are delivering with this embedded Kubernetes runtime that exposes not only a declarative API that is Kubernetes-based, but also this set of services that gives you all of these capabilities that you can add and consume on the platform. With this, you can deliver virtual machines, you can deploy Kubernetes clusters, but also all of the other resources you would be deploying on your platform, whether they're storage resources or, for example, network resources like load balancers, and anything else using a single declarative API. And the other advantage of this ecosystem is that it is extremely expandable, and you can customize it to your needs and to the needs of your workload. So you can add new functionality to the platform to allow that. But most importantly, any new functionality that you will add into this ecosystem will still receive the same consistent consumption experience for your consumers. And the other thing that's also worth mentioning is that it also provides this additional layer of abstraction of the underlying infrastructure for your consumers on the platform. So let's specifically talk about what are some of the improvements that we have made for cloud admins. And it all starts with enablement. One of the new things that we have introduced is that you are able to enable vSphere Supervisor, this declarative API and the set of services directly during the creation of a workload domain. This means that you only have to provide minimal information and minimal input when you are creating your workload domain, and select the pre-existing NSX managers and VPCs that are configured in order to enable Supervisor. This makes it much easier for you to enable it and also to be able to do that at scale as you are creating your workload domain. When we're deploying the resources on this platform, they are always grouped in these logical units called vSphere namespaces. And what we have delivered in vSphere 9 is a tight integration with the VPC-based networking that allows us to create even greater network isolation for your workload. And they also then act as this entry point into the consumer ecosystem, where the admins can still control what is available within the namespaces, but the consumers can then access them and deploy their resources. So we use these to, for example, set resource limits and quotas. We use it also to maybe manage what kind of content can be deployed within these isolation units, and also the networking details. But one of the new things that has been a big ask from our customers for a long time was to be able to create this separation between the management and workload zones of a supervisor. And that's something that we are delivering in VCF 9. When you first enable supervisor, the first cluster that will be created will be marked as a management zone, but you will then have the ability to add additional zones to supervisor without having to deploy additional control plane nodes to reduce the footprint and to give you a greater possibilities of how you want to structure your infrastructure. Once you add additional zones, you can also then expand these namespaces to use multiple of these simply within the user interface. The other improvement I would like to mention is that we understand that sometimes, especially for cloud admins or traditional VI admins, the step into the Kubernetes world may be a little bit tricky. And in order for you to be able to do all of the configuration that is required, sometimes it requires knowledge about certain objects. In order for it to be easier for the cloud admins, we have introduced a new role in vCenter, specifically for supervisor administration. So now you can empower these platform operators to be able to do the tasks that are required in order to manage the ecosystem, whether that's the updates of the supervisor or any kind of management of the supervisor services that can get deployed onto the platform. And another new thing that we are introducing now is that we have also created an asynchronous release mechanism for supervisor updates. So what this will mean is that we will be delivering new versions independently and very quickly to unlock new functionalities for you that you can then implement in the platform really quickly. And the last thing I want to quickly mention before I start showing you some things is that we also have a brand new CLI, and that's our VCF CLI, which will be providing this unified experience for all of the CLI needs that you have in VCF 9. And with that, let me quickly jump into the first demo, in which I would like to show you some of the basic introduction into the supervisor ecosystem. So in this environment, you will see that we have a workload domain created with a supervisor enabled. If you have worked with supervisor before, you may have noticed that we used to deploy 3 control plane virtual machines. In order to reduce the footprint of supervisor, we have now changed this default configuration to a single control plane VM. So the resources that are required in order to enable this are much smaller. And if we start now, we will see we have this single control plane. And if we go into our supervisor management, and under supervisor, we can see our configuration, we can see the version that we have deployed, and we can also see the status of the API server. And as I mentioned, any new supervisor that you will create by default the first zone in marked as management, and you can then go ahead and add additional zones as required. And as I mentioned, the default configuration being a single control plane that is deployed, you always have the possibility to enable high availability. You can very simply do it through the user interface, simply by clicking the activate button in the configuration of the control plane. Once you do this, this will trigger a deployment of 2 additional control plane nodes in order to receive 3 and configure high availability. And as always, you can always check what the current status of the tasks is. You can see the additional VMs being deployed and configured. Okay, and with that, we do have our environment ready for consumption. And as you can see, we now have 3 control plane VMs. So that was a quick intro. And now let's go back and start talking about more services. So the first service I would like to talk about specifically is our VM service. VM service is a way for you to deploy virtual machines, but using these modernized methods and using the same declarative API. What this means is that now for virtual machine management, you define the desired state of the virtual machine, the state which you want to achieve, and you let the system handle how that state gets achieved. We have some new capabilities in VCF 9 as well when it comes to VM service. We can deploy not only from OVF templates, but now also from ISO, and we can also do more with our VM classes. A VM class is a definition of the hardware configuration of a virtual machine that you are deploying. But in order to explain this a little bit easier, I will show you a quick demo of our VM service. And in this demo, we will start with a simple deployment. So as you can see, I am in our VCF automation as a consumer, and I have access to the namespace that has been configured and also to the services that I can start to consume to deploy my workload. So for virtual machines, as mentioned, we can deploy from OVF or now also ISO. I will just give the virtual machine a quick name. The next thing we can select is a zone where this should be deployed. If we do select the zone, it will allow us to deploy some storage volumes and attach them to the machines. So we will do that. Next, I'm going to select a VM image that should be used for the deployment of the virtual machine, followed by the VM class. So again, this is the hardware specification for my virtual machine. So configuring things like my CPU and memory and any hardware resources. If I wanted to, I could just deploy the virtual machine as is, but I want to show you some advanced options as well. First of all, we can attach persistent volumes. So keeping in mind that by default, in order to deliver data persistency for my virtual machines, I need to create a persistent volume. So I'm just going to request this in this flow, and the storage service within the platform will go ahead and do that for me. The same goes if we want to create load balancers on demand. So I'm just going to create one to be able to SSH to my VM. But what I want to talk about in a bit more detail now is the changes and new additions that we have done in our guest customization. So for the virtual machines that we are deploying, we can do the full bootstrapping of the virtual machine and full configuration during its first boot. And we can either use Cloud Init if you're using Linux-based VMs, or if you're using Windows, you can use sysprep. But we have introduced a lot of new capabilities directly in the UI to make it easier for you to deploy these virtual machines. So with Cloud Init, for example, we have implemented some guided inputs that you can utilize directly in the user interface, but you can still use the raw configuration. So if you would be using that, you would just paste your cloud config directly into here. But I wanted to show you an example of how to deploy a quick virtual machine and use these options. So I'm just going to create a new user called DevOps. I'm going to enable SSH authentication for this user as well, so we can log into the VM afterwards. And now, if I want to run any commands, I can add the list of commands that I would like to run here. This is just a quick example, and you can add as many as you want to fully configure your virtual machine. Next, we have added some additional things for our network configuration. So here you will be able to add additional network interfaces for your virtual machine, but also configure things like host name or domain name, for example, and also DNS settings for your virtual machines if you require. And as always, the full YAML manifest has been created on this right-hand side and can be downloaded not only for the virtual machine, but for all of the objects that we have been requesting during this flow. So we can go ahead and deploy that. And once our VM is ready, if we go into the volume service, we can see the persistent volume that we have requested and attached. So we can see it's bound to our virtual machine. And also under network, we will be able to see the external IP of that load balancer we have deployed. I can now SSH onto this VM using the DevOps user that I have created. And once I log in, I will be able to verify that it worked as expected. We can also do some other operations now with our VM. So for example, if I would want to change the compute resources of my virtual machine, I can go ahead and directly from this view, I can do power operations. So I can power off my virtual machine, but I can also go and change that VM class that defines my hardware configuration. So for example, I can decide to maybe add a little bit more memory to my virtual machine. So I change the VM class to a larger size. I can then again power on my virtual machine. And if I go back to my inventory, where I can see my virtual machine sitting in the inventory within the namespace where I'm operating, in here I can see that it has already greater memory that is attached. And also, if I go back to the virtual machine, I will be able to see the resources that are free. So those are some of the operations we have with virtual machines. Now, the next big service, probably very interesting for this topic as well, is our vSphere Kubernetes service. So let's quickly jump into that. Our vSphere Kubernetes Service, or VKS, allows you to deploy fully conformant Kubernetes clusters on demand in a matter of just a few minutes. We'll go through a demo where you can see how simple it is to deploy them. With VCF 9, we have delivered version of Kubernetes VKS 3.3 that is embedded in when you enable Supervisor. And with this, we support Kubernetes 1 to 32. All of our clusters that we are deploying are bootstrapped and configured using Cluster API. In terms of operating systems, we do support Photon OS, Ubuntu, and also Windows. And again, most importantly, the idea of service is to give you a very quick Kubernetes service that is on demand and very easy for you to deploy clusters of any configuration that you want, any sizing that you want, and as many as you want to deploy. But that's not all, because we have really committed to delivering new Kubernetes versions faster and faster. Ever since we have decoupled our VKS release, we've been giving you more releases really frequently. As I mentioned, with VCF 9, we are supporting Kubernetes 1.32. However, at the same day of the GA of VCF 9, we have also released VKS 3.4, which gives you support for Kubernetes 1.33 and some other new capabilities, which are really exciting. So let's quickly discuss how can you enable this in your environment. And the first thing you need to do when you are when you want to allow your consumers to be able to use these new versions is to manage the version of the service itself. So we will go through a little demo where I'm logged in as a consumer, and I want to go and deploy a Kubernetes cluster. Now, if I go to deploy a Kubernetes cluster, I can select custom configuration, and I can see which Kubernetes releases are available to me in the user interface. So as you can see, this is VCF 9, so there's Kubernetes release 1.32. What I can also do is check what is available for me using a CLI. So if I prefer to work in CLI, I can simply go ahead and see which Kubernetes releases are available to me. Now, what you will notice is that there's a list of Kubernetes releases. We do deliver these using a subscribed content library where we introduce all new versions. And in here, you will see that I can already see that there's a version 1.33 that is available, but it's currently marked as false because it's not compatible. The reason for that is because the version of the service needs to be updated first. So as a consumer, I would have to request that the service is updated. This is something that could be very easily done by the cloud admin. So let's quickly go through the process of updating the service. So in our environment, if we go to Supervisors Management and Services, you will see we have our Kubernetes service deployed there. Now, if we go to Manage Service, you will see that the installed version is 3.3.1 embedded. So this is the version that you get when you enable Supervisor for the first time. You can see that in here. So now what we need to do is we need to go and download a definition for the new version of the service. So following the link from the UI, you will be able to list all of the versions that are currently available. And as you can see, there's already VKS 3.4. You can also access the release notes from here. So it's really easy for you to access that and get that information. You can download the new versions of the service from our support portal. So in here, under Kubernetes Service, I will go into my release version and just download a simple YAML manifest, which is the service definition file for this service. And now under Actions, I can go ahead and add a new version. And I will just very simply upload this YAML manifest that I have just downloaded. I don't have to do anything else. So just upload that, click Finish. And after a while, we will see that the active versions will change to 2. Once I see that there are 2 active versions, I can go ahead and install this version. So in here, I can go to Manage Service, select the version I want to install, select the supervisor where I'm installing this, and click Next. This will run through quick compatibility checks. If you are running supervisor with a single control plane, it will give you this kind of warning just to let you know that you're running in that configuration. If you would be running the high availability control plane, you will not see this warning. You can accept this and proceed. Leave the defaults of the configuration and just wait for this to complete the action. So you will see that the service is now configuring. After a while, it's configured. And now what we can do, if we go back to our CLI and check our versions again, you will see that now we can see that 133 is now compatible. So it's true. Going back to our user interface, we can go to the deployment, and you will see that if you want to deploy a default configuration of a cluster, which is the quickest way to deploy a Kubernetes cluster, it grabs the latest version that is available. So as you can see, it is now grabbing the version 133, which is available for us. So we can just go ahead, deploy a cluster really easily, grab the kube config, and start working with it. So that's how you would go ahead and update the service. Every time we release a new VKS version, this is the process that you would follow to add the new version and unlock the new versions. So let's talk a bit more about all of the possibilities that we have and all of the capabilities we have with VKS deployment. So in this, we'll just go through a full cluster deployment. So as I mentioned, when you're deploying clusters, you can either go with default configuration. This is extremely helpful if you just want to deploy a very quick cluster with a simple configuration. It has a single control plane node and a single work node. Just click Next and Finish. Literally in 2 steps, you will have a fully functional Kubernetes cluster. But for the purposes of this demonstration, we will do a custom configuration. So we'll select that and click Next. You will see that we have introduced a lot more options in the user interface directly to help you with the configuration of the cluster. But still keep in mind that this is not the full set of the API. If you want to add even more capabilities, you can always do that directly by creating the YAML manifest. But most of the most common options will be available directly through this user interface. So let's go through some of those. So I'm going to give my cluster a name. Again, we have our Kubernetes releases. So now we are selecting version 1.33. You have also added a few more options here, directly adding labels or some taint, maybe adding volumes. You will also notice that our certificate rotation is enabled by default, set to 90 days, really important. Some further configuration for FQDNs, NTP servers, maybe some proxy or our networking settings. Then we can go ahead and configure our control plane. So again, selecting how many control plane replicas we want to have for our Kubernetes cluster, default being 1, you can select 3. Using a VM class to define the resources for the control plane nodes. And also the storage class and OS images. So you will notice this is coming from the subscribed content library called Kubernetes Service Content Library. The reason why there are 2 Ubuntu releases now is that we have also introduced long-term support for Ubuntu 24.04, which is in the content library now, and you can use that. At the same time, with VKR or vSphere Kubernetes release 1.33, we are introducing extended support for this release as well. So we can select the operating system for our control plane. So our control plane will always stay Linux-based, but you can choose between Photon or Ubuntu. And now we can configure our node pools. So in here, we can, again, configure name of the node pool, configure replicas, configure the hardware configuration of the nodes with VM classes, operating systems, but also we can do labels and taints directly and also configure additional volumes if we need to. So labels are very helpful to be attached to the nodes during this deployment flow, and also taint if you do require them. And in terms of volumes, if you are running any AI/ML workloads, any operators that require more space in order to run effectively, you can directly request additional volumes from this deployment flow as well. As always with node pools, you can create multiple node pools, maybe add different configuration of nodes into your cluster if you require that, maybe different sizing or different operating system. For our work nodes, we do support Photon, Ubuntu, but also Windows-based workloads, Windows-based worker nodes to support your Windows container need. And again, the full YAML manifest has been created for us. So if you want, you can go ahead and download this to reuse it later. But also, as I mentioned, always keeping in mind that this is not the full set of the API capability. So it's very useful, for example, to do the base structure, download it, and maybe add any additional fields that you require. So with that, we can just go finish and deploy our cluster. And once our cluster is ready, again, directly within my user interface, I can see the volume that I have requested, that it has been created and bound to my cluster. I can see the load balancer that was created for my cluster because the control plane needs to be fronted by one, and also the virtual machines that make up this Kubernetes cluster. So VKS is actually using our VM service in order to deliver the virtual machines that are created for this Kubernetes cluster. You can always filter them out if you want to have a clear view of just your virtual machines. And now there are multiple ways of working with our Kubernetes clusters and how we can log in. We also introduced this new unified VCF CLI that you can use to access your clusters. We do have a special plugin for cluster that we can simply install. And then what we can do is we can just go ahead and register this cluster and grab its uconfig to be able to log into this using the VCF CLI and also our kubectl command. So I'm just going to quickly get that. And I can now access my cluster using the CLI as well. So very simply, I can check that my nodes are available. Okay, and now let's continue with some of the other stuff we have. So as I mentioned, we created this ecosystem in order to be able to introduce new services that can be simply added onto the platform and give you this extended capability. And one of the new services that we have introduced is our secret store. In order to give you this centralized secret management directly within your ecosystem, and with that, consumers can create and manage secrets, and then also inject them into all of the workloads that are deployed on this platform, whether that's Kubernetes clusters, virtual machines, or any vSphere pods. So with this, I do have a quick demo of how that is deployed as well. So in here, I'm going to show you a slightly different process of introducing new functionality from the perspective, starting with the provider or the cloud admin, enabling functionality for consumers to later use. So in here, again, back in my automation portal as a provider, I have a list of services that I can add and enable. And one of them is my secret store service. So what I'm going to do here is I'm going to go into actions and I'm going to install this. I'm going to accept the agreement after reading it. Next, I can select whether I want to enable this service to all of the regions that are available or a specific one. So in this case, I will just choose a specific region. I will select that region from the list. You can see that it's ready and it has the supervisor listed here. And next, some of the services may require some additional configuration. For example, specifically Secret Store needs you to configure the name of the storage class that should be used. So we will quickly add that and just submit this. Now we will just wait for this service to become healthy, which means that it is fully deployed. So we switch back into our vSphere client view and our inventory view. You will see that this service has been deployed in its own service namespace. So we can quickly go in there, and under compute, we can see the pods that were deployed in order to deploy the service. So this is now fully enabled for our consumers. And now as a consumer, now I'm back in, but now in the consumer view, I can go into my namespace, and you will notice that now under services, I do have a new service available for secret. So I can go ahead and create a new secret. For example, if I want to create a new user, I can just give it a name and then create my key value pair in here. So I can directly create and manage my secrets from my user interface and then use these to inject them into my workload. And the last thing I would like to cover in this short amount of time is a a way for you to be able to get your hands on this really quickly, if you want to get familiar with this functionality, maybe in a POC environment or in a lab environment that you are deploying, we have introduced this concept of a easy supervisor. And this introduces this modular approach to everything that I have just shown you. It's supported on VDS networking, and it gives you the supervisor enablement in few very simple steps. In the first step, all you have to do is to enable this is simply right-click, enable the supervisor. This will give you that declarative API that you need to communicate with, and also the ability to use VM service. Once you have that configured, you can move on to step 2, which is to add a load balancer in order to unlock the further capabilities like VKS, because those require load balancer. And then you can decide whether you want to, again, scale the control plane out to 3 control plane nodes or keep it on a single, or if you want to add any additional networks. And in order to add a load balancer, which is always an important part of this puzzle, we are also introducing a completely new out-of-the-box load balancer that comes with called Foundation Load Balancer, which you can deploy very simply directly from the UI and use for this purpose. So what I'm going to do now is I'm going to show you a quick demo of how that setup works. So as I mentioned, this is my test environment. So as you will see, it's very, very simple. I have a cluster here that is just very simply configured with VDS networking. I will then go ahead and right-click, activate supervisor, select static IPs for my environment, select the network that I want to do, and just do some very basic network configuration. So as you can see, all I'm giving it is some IP range, subnet mask that I need, gateway, NTP, DNS. Very, very simple configuration that is required. Selecting the storage policy for my objects, giving it a name, and clicking activate. That's all that's needed for this to be enabled. So I will very quickly just show you this is now configured. So at this point, you will be able to interact with the declarative API, and as I mentioned, deploy virtual machines. And it's configured with that single control plane. Now, if I want to add that additional functionality, I can go to the configuration of the supervisor. So just going through the menu into supervisor management, the supervisor, and under configure, if I check my network, there's a section for load balancer. Now I can go ahead and add a load balancer. As you can see here, I can choose which load balancer I want to add. I'll select Foundation Load Balancer, and you will see that, again, extremely simple to get you going very quickly. There are different network topologies that are available for this deployment. You can select depending on how you want to split your networks. There's additional information here. For the purposes of my lab, just as a showcase, it's going to be a very simple configuration and topology of a single network. I can select how many nodes do I want to deploy, and then configure my network. So it also shows you directly highlighting where this traffic will be going. So this is the network that the supervisor uses. Again, we'll just give it a very quick range of virtual IPs that it can use, and that's all that's required. So directly, very simply, I can add a load balancer and unlock the further capabilities. So under configuration, you will notice that it is now deploying those additional core services. So it's running through that configuration. And once that's configured and ready, we can go back and we will see that now we have also our load balancer deployed. And we can now deploy VKS clusters as well. and any other resources that we require. And as I mentioned, there's also step 3 and step 4 if you choose to do so. So step 3, for example, again, if I want to activate high availability on this control plane node, I can just quickly do that here. Activate, it will deploy additional control plane VMs. Or if I wanted to add initial networks, as you could see, you can configure that directly in your configuration and use that. So this is really a way of giving you something that you can very quickly go and configure and start getting familiar with the services and use them. It's a great way of achieving that. And with that, let's just go back in here. Hopefully this has given you some ideas about what we are delivering in VCF 9. And we'd also like to mention at the end of the session that please register for our upcoming Explore. There will be much more, a lot of sessions that will be really interesting, a lot of technical sessions, media experts, breakout, keynote, everything you want to have. You will also be able to attend a lot of hands-on labs on site. You will also be able to take free certification and other advantages. So please go and register, and I'll see you there. And with that, thank you very much. And thank you very much for my colleagues in chat who are helping me answering all of the questions.